In this tutorial, we're going to take a look at solving a number of different linear equations. And the first 5 examples, the first 4 on this page, and page 2 is a 5th example, are all ones that have some terms on both sides, some numbers, some brackets, but no fractions. We will get into a couple that have fractions in the last 2 examples on the 3rd page. So first of all, example number 1, solve 4w equals 12. Now this means that 4 times some number I'm trying to figure out is equal to 12. Now I don't want to know what 4 times number is, I want to know what the number is. So this w is multiplied by 4. So the way we isolate the w or solve for the w or get the w alone, those all mean the same thing, is because the w is multiplied by 4, I'm going to divide both sides by 4. Like this. And so 12 divided by 4 is 3. Now I use the words divide out. The 4 divides out. What that means is that this 4 divides into this 4, leaving a coefficient of 1 here. And we don't normally write a coefficient of 1, but it's changed it so it's not a 4w on the left anymore, it's just a 1w. So this tells me that 1w, or just w, is equal to 3. Now I think that 3 is my solution. So this is how you check. You take, and the only place there's any kind of an expression is the left. The left, and ls stands for left side, is 4w. So I'm going to put the 3 in place of w here. So 4 times 3 works out to be 12. Now there's nothing to evaluate on the right side. The right side was originally the number 12, and the left side worked out to have the same value of 12. So that equals the right side, so that's how we know that 3 is the solution or the root to this equation. Now if we had made a mistake, let's say we thought for some reason that w wasn't 3, let's say we thought that it was 5, for example. If I checked, if I put a 5 in here in place of w, 4 times 5 is 20, you'll see it doesn't equal what's on the right side. So that's how I know that 5 is not the correct solution, but 3 is. Example number 2, we're asked to solve t minus 6 equals 10. Now the t has a 6 subtracted from it, so to isolate the t, we do the opposite of subtracting 6, which would be to add 6. So I'm going to add 6 to both sides. Now you always have to do the same thing to both sides. In the first example I divided by 4. In this one I'm adding 6 to both sides. So this minus 6 and plus 6 here, those two terms add to 0. See this, if we add those together, that gives you 0. Like subtracting 6 and adding 6 has a net value of 0. So on the left here, this just simplifies to t, and 10 plus 6 is 16. So t is equal to 16. So we think that t is 16. So we're going to substitute 16 in place of the left side, in t in the left side expression. The left side expression is the t minus 6. So here's my check. And so I'm going to put 16 right here. So 16 minus 6 equals 10, and 10 is what was on the right side originally, so that equals the right side. So that's how we know that 16 is the correct root or solution or answer. In example number 3, you're asked to solve 3x minus 5 equals 16. Now the 3x has actually, well, I'll leave that on there. So these are actually called, the first and second example are called one-step equations by some people because there's one step to solve them. This is called a two-step because there's actually 2 things to do. You see, the x has 3 multiplied by it, and then 5 is subtracted to give me 16. So that's kind of like the 2 steps here. So what I want to do first is get the term that has the x alone. Okay, and then I'll get rid of the 3 after that. So the 3x has a 5 subtracted from it. So the opposite of subtracting 5 is to add 5. So that's why I'm adding 5 to both sides here. Now on the left, once again, those add to 0. So that's why we're just going to have a 3x on the left here. And 16 and 5 add to 21. So this tells me that 3 times x is 21. Again, I want to know what x is, not what 3 times x is. So because the x is multiplied by 3, the opposite of multiplying by 3 is to divide by 3. So I'm going to divide by 3, and The 3's divide out. 3 divided by 3 is 1. So that just gives me a 1x on the left equals, and 21 divided by 3 is 7. So x is 7. So we think the 7 is the solution here, the root of our equation. So I'm going to substitute 7 in place of x in my left side expression. So the left side expression is a 3x minus 5, so I'm going to put a 7 right there. So 3 times 7 minus 5, so remember your bed mass. 3 times 7 gets done first before you subtract the 5, so that's 21 minus 5, works out to be 16. Well, that's good because what was on the right side originally was 16. So that equals the right side expression. So that's how we know that 7 is the solution to this equation. In example number 4, we're asked to solve 7x minus 6 equals 2x plus 24. So there's x's on both sides. There's numbers on both sides. So we want to rearrange it so we have the x's on one side and the numbers on the other. And it really doesn't matter if the x is on the left or on the right and the numbers on the other side. A lot of people sort of get into the habit of putting the x's on the left all the time, but it doesn't have to be that way. Okay, so I am going to do that in this case. So in my strategy to get the x's on the left would be to get, okay, I want to get rid of the number on the left side here, the minus 6. So the opposite of subtracting 6 is to add 6. So I'm going to add 6 to the left side, and I'm going to add 6 to the right side. There's my two 6's I'm adding. So on the left here, 6 and subtract 6 add to 0. So this is going to simplify to just 7x on the left, and then we have a 2x over here, and we can add the 24 and 6 to get 30. Now that I got the numbers, I only have one number here. It's on the right side, which is where I want it to be. Okay, because I'm going to put the x's on the left. So the 2x is a positive 2x. So the way I get rid of that 2x is I'm going to subtract 2x from both sides. See, that's that 2x, and I'm doing the opposite. I'm subtracting 2x. So that's going to add to 0. So on the left here, 7x minus 2x is 5x, and that's 0. So we have just a 30 here. So this tells me that 5 times some unknown number is 30. So I want to know what x is, not what 5 times the number is. So we divide out the 5. The 5's divide out, and 30 divided by 5 is 6. So I think that my answer is 6 here. So we want to check. So on the left side, we're going to put 6 here in place of x. So 7x minus 6 is our left side expression. So we're going to put this 6 right here, not to be confused with the 6 that's subtracted on the end. So 7 times 6 is 42, minus 6 works out to be 36. Now, the right side isn't a number like it was in the previous examples. So we have to evaluate the right side expression too. So the right side is this 2x plus 24. So I'm going to put my 6 in here in place of x. And of course, we want this to evaluate to the same thing that's the left side. The left side gave us a value of 36. So we're going to put the 6 here. 2 times 6, that works out to be 12 plus the 24. And 12 and 24 do add to 36. So because the left side and right side values worked out to be the same thing, it really doesn't matter what that number is, just that it's the same. That means that 6 is the root of our equation, or the solution to our equation. Example number 5 here. Now, what makes this just a little bit different is I have this negative 4 out front of the brackets here. And so the first thing that I would do is I would distribute in the negative 4 into the brackets here. So if I multiply negative 4 by 2x, that gives me a negative 8x. And negative 4 gets multiplied by the negative 3 as well, which is plus 12. And so I'm not doing anything to the right side. I'm just going to leave the negative 2x plus 3 alone for the moment. Now, I called this a negative 3 here. Before we get to the next line, I want to talk about something here. It is a subtract 3, but, and maybe I'll write this over here. So let's say, see what we have on the left here is this. So what I want to point out, this is why we can consider that to be a negative instead of a subtraction sign. I got my 2x in here. So 2x has 3 subtracted from it. Subtracting 3 is the same as adding negative 3. So when I multiply by negative 4 by the 2x, I get the negative 8x out front. And negative 4 times negative 3 is positive 12. So we actually have plus a positive 12 here. So plus a positive 12 is the same as just plus 12. That's why we write it just plus 12. So now it's like the last example, example 4. I have x's on both sides, I have numbers on both sides, and I'm going to rearrange it so that I have the x's on the left and the numbers on the right, but you could do it the other way, it wouldn't matter. So if I want to get the numbers over to the right side, the first thing I'm going to do is get rid of this 12. The 12 is added to the negative 8x, so the opposite of adding 12 would be to subtract 12. So there's my minus 12, and I'll write the minus 12 after the 3. I could write it here, it wouldn't matter. The reason I write after the 3 is because it's being subtracted from the 3, and we'll get a number there in a moment. So this adds to 0. 12 minus 12 is 0, or subtracts to 0. So we just have negative 8x on the left. And 3 take away 12 is minus 9. So the negative 2x minus 9 is what's on the right side. Now, I want to get the x's on the left. I handled the numbers. I only have one number. It's on the right side. So we've got a minus 2x here. So now I could subtract negative 2x, but that's the same as adding 2x. So if I have a negative 2x and I add 2x to it, that gives me 0. So that's how I get rid of the x's on the right side. So I'm going to add 2x to both sides. So this is 0 here. Negative 8x plus 2x is negative 6x, and that's 0. So we just have the negative 9 on the right. Now, I'm not writing as a subtract anymore because it's just the number negative 9. And so in order to solve for x, I will divide out this negative 6. So those divide out, so I get x is negative 9 over negative 6. I can divide both of these by negative 3. If I divide them both by negative 3, it simplifies to 3 halves, 3 over 2, or 1.5 if you want to write it as a decimal. So let's check this now. So my left side expression is this. So I'm going to put the 3 halves in place of x right there. So 3 halves. Now this 2 that's multiplied by 3 halves, that's the same as 2 over 1. So the numerator of 2 gets multiplied by the numerator of 3 to give us a numerator of 6. And in the denominator, 1 times 2 is 2. Now, 6 divided by 2 is 3. So in the brackets, this is really just 3 minus 3. And I'm doing BEDMAS here, so I'm evaluating what's in the brackets first. So 3 minus 3 is 0. So 0 multiplied by negative 4 is 0. So that's what the left side works out to be. Hopefully the right side, when we put this 3 halves in here, is going to give us 0 as well, because if it does, that means that this is the solution. So here's my right side expression, negative 2x plus 3. So I'm going to put the 3 halves over here, just like I put the 3 halves in place of x there. So it looks like this. And just like before, this, well, it was a 2, I guess, before. This is a negative 2. Negative 2 over 1 has a denominator of 1. So negative 2 times 3 is negative 6 in the numerator. 1 times 2 is 2 in the denominator. Negative 6 divided by 2 is negative 3. Plus the 3 gives us 0. So since the left and right sides are both the same, they both evaluate to 0, then that means that x is 3 halves, or 1.5. Example number 6. We've got, so I said at the beginning there are going to be some examples with some fractions in the equation. So there's 1 here. It's actually 2 in this one. So the thing to do first when you have fractions in your equations, okay, not fractions as a solution like the last example had, but fractions in the equation from the beginning, is we want to multiply by a number so those fractions, we get rid of the fractions. So the only fraction here is the 1/4, 1 over 4. So I'm going to multiply both sides by 4 because that's the denominator in this fraction. Okay? It doesn't really matter in the fraction what the numerator is. That 1 could be any number. I would still multiply by 4 because there's a 4 in the denominator. So this right here is being multiplied by 4, and the negative x is being multiplied by 4. I just put brackets around that just to make it a little clearer that that is what's being multiplied by 4. Now, the 4's divide out. That was the reason for multiplying by 4. See, 4 divided by 4 is 1. And so that's, well, there's actually a 1 here if you want to put it. This 1 gets multiplied by this 1, which of course is still 1. And so what's on the left here is really just 1 times the 2x minus 3. So if I expand this 1 into the brackets, and if it's a number besides 1, I would, whatever it would be, I would multiply it in, then that's what's going to be in the left side. So 1 times 2x is 2x, 1 times negative 3 is negative 3, and it won't be a 1 in the next example, so I'll handle that in example 7. On the right side here, negative x times 4 is negative 4x. Now, we've been doing a lot of rearranging, putting x terms, variable terms on the left, number terms on the right. This is one of the times when I'm going to do the opposite, because it's a little quicker to do the opposite here. You see, I only have one number, and it's on the left side. So if I put the numbers on the left, well, the number's already there. I don't need to move it. So I'm going to get the x's on the right side. So I'm going to get rid of this 2x here so that there are only x terms on the right side. And the 2x, in order to get rid of it, I would subtract 2x from both sides. So 2x minus 2x is going to be nothing. I'll just have the negative 3 on the left here. So you see, I'm subtracting the 2x on both sides right there as well. So negative 3 is on the left. Negative 4x minus 2x is negative 6x. And I want to solve for x here, so I'm going to divide out this negative 6. I want to get the x alone. So whatever the coefficient is of the x, I'm going to divide that out. So divide the negative 6, so that divides out, so we just have an x here. Negative 3 over negative 6 is the same as a half. I can divide both of these by negative 3 and get 1 over 2, or a half. So I can write a half equals x or x equals a half. It doesn't matter. Those both mean the same thing. So let's check this now. Here's my left side expression. So I'm going to put the half in place of x right there. And so I'm multiplying 2 by a half, and again, has a denominator of 1. So in the numerator, 2 times 1 is 2. And so maybe I'll write this out. That's actually 2. And in the denominator, 1 times 2 is also 2. So that actually simplifies to just 2 over 2, which is equal to 1. So that's where that 1 comes from. So we have a quarter times, in the brackets, 1 minus 3. Bedmass, I'm going to do what's in the brackets first. 1 minus 3 is negative 2. And just like all the other times before, that integer has a denominator of 1. So if I multiply 1 by negative 2, I get negative 2. 4 times 1 is 4 in the denominator. And that simplifies. I can divide a negative 2, or, well, I'll just divide a 2 out of this to give us negative a half for an answer. So that's what the left side works out to be, negative a half. So the right side is this expression. It's a pretty simple expression. It's just negative x. Remember, we thought our answer was a half, so I'm going to put a half in here. And very quickly, the right side evaluates to exactly the same thing the left did. They're both negative a half. So not to be confused with the solution that was a half. So the right and left side are the same, so x is equal to a half. A half is the root. Okay, last example here, number 7. I have 4a minus 1 over 7 equals 3a minus 1 over 5. Now, this equation is the same as if I wrote this, just to show you that if you see this, it means the same thing. Whoops, that's supposed to be... I'm just going to erase a little bit there. There we go. And because the right side is over 5, it's the same as having 1/5 times the 3a minus 1. So, if you see those, these two equations are exactly the same. I can write 4a minus 1 over 7, or I can write 1/7 times the 4a minus 1. I can write 3a minus 1 over 5 or 1/5 times 3a minus 1. They mean the same thing, and they're solved exactly the same way. There is no difference between them, even though they may look a little bit different. Now, we have two different denominators. That's what separates this from example 6. So, what do I multiply by so that the 7 divides out and also the 5? It's actually the least common multiple of 7 and 5. Actually, any common multiple of 7 and 5 will work. We use the smallest one, so the numbers are as small as possible. So, to see what the least common multiple is, I'm going to write out the multiples of 5 and 7, the first several multiples. And you see the first number that appears in both lists is the least common multiple. There's another common multiple a little further along here. 70 is in both lists if you write a few more out, but it's not the smallest one. 70 would also work. It would give exactly the same solution. Your numbers would just be a little bigger when you use it. So, because the least common multiple is 35, I'm going to multiply both sides of this by 35. And that's what it looks like. Now, the idea is this. This 7 goes into the 35, or divides into the 35 evenly. And 7 goes into 35 5 times. So we leave a 5 here. We'll get to that in a moment. Over here, this 5 goes into this 35 7 times. So I'll put a 7 right here. Now, this 5 is going to get distributed into the 4a minus 1 brackets, and the 7 is going to get distributed into the 3a minus 1 brackets. I'm going to write that step out. I could have actually just done it, I suppose, but I'm trying to explain how these things work, so I don't want to do too many steps at once. So this is what all this simplifies to. Notice no fractions anymore. Okay, that's what we want to do. That's the reason we multiply by the 35. So we distribute the 5 in here. 5 times 4a is 20a. 5 times negative 1 is minus 5. 7 times 3a is 21a. And 7 times negative 1 is minus 7. Now I want to simplify this so that I get the a terms on one side, the numbers on the other. So I'm going to go back to the normal variables on the left, numbers on the right, but I could do the opposite. So I'm going to get rid of the 5 first. So the opposite of subtracting 5 would be to add 5. So I'm going to add 5 to both sides here. So that adds to 0. So we just have the 20a on the left and equals 21a, and negative 7 plus 5 is minus 2. Now I'm kind of running out of room here, so I'm going to go up here and continue here under my two lists of numbers. So I want to get rid of the 21a from the right. So it's a positive 21a. So I would take 21a away from both sides. So there's my taking a 21a away. That adds to 0. 20a minus 21a is just negative a. And that is the 0, so we just had the minus 2 on the left here. Now there's a negative 1 right here. We don't normally write it, but there is a negative 1 right there. So I'm going to divide out the negative 1. And so the negative 1's divide out to give me just a on the left here, and negative 2 divided by negative 1 is 2. So I think 2 is my solution. So I'm going to put 2 in place of a here. So that's my left side expression. So 2 is going to go here. 4 times 2 is 8. And so 8 minus 1 is 7. So I have a 7 in the numerator here, divided by a 7 in the denominator, which gives me 1. So let's look at the right side now, the 3a minus 1 over 5. So and again, 2 is what I think my solution is. So I'm going to put a 2 here. 3 times 2 minus 1 over 5. And 3 times 2 is 6. So in the numerator, we have 6 minus 1, that's 5, and 5 divided by 5 is 1 again. So the left and right sides are the same, so that means that a does equal 2. And that's the end of the tutorial.